Hello class 6 students, how are you all? I am Monica Bajaj, your science teacher, and today we will discuss about your unit number 5, how things work. Chapter number 12, electricity and circuit. Electricity. Electricity is a form of energy which is very useful in our daily life. In fact, it is difficult to imagine our lives without electricity. It is a convenient and useful form of energy which is used to supply current for the purpose of heating, lighting, etc. Its importance in our daily life can easily be realized when power supply in our homes breaks down suddenly. Electricity generation. There are three types of power plants which are used for generating electricity on a large scale. These are: first, thermal power plants. Thermal power plants are based on coal, diesel or natural gas. Second one is atomic power plant. These are based on the nuclear fission of uranium-235. Third one is hydroelectricity power plant or hydel power plant. These are based on force of water. In these plants, kinetic energy of moving water is used to generate electricity. The electricity we use at home and at shops comes from power stations. Electric torch. An electric torch is a simple device. It consists of following component. First one is bulb. It produces light when electricity passes through it. A bulb consists of a thin tungsten wire called filament. The filament is enclosed in a glass enclosure. The bulb has two terminals. When current flows through the filament, it heats up and the filament gets hot. It starts glowing. This glow is the source of light of the bulb. Reflector and lens. They focus the light produced by the bulb. Next is battery. It acts as a source of electricity. Next one is plastic body. It holds all the part of the torch. Next is switch. It is used to switch the torch on or off. A switch controls the flow of current through the bulb. Let's see the diagram of the torch for our better understanding. Working of an electric torch. When the torch is in on position, the circuit behaves as a closed circuit. Current flows through the bulb and it glows, thus producing light. When the switch is in off position, the current behaves as on open current. The circuit behaves as an open circuit. As there is no flow of current, no light is produced. Let's see an activity. Aim of the activity: to make a torch. Material required: 3 pieces of connecting wires, a torch bulb, electrician's tape, aluminium clip and a dry cell. Procedure of the activity: take the electric wire and scrap about 2 cm of plastic covering from both the end of the exposed the metal wires. Take a torch bulb and fix 2 electric wires to its terminals as shown in the figure. Use electrician's tape to fix all the wires. Join the free end of one of the wires of the bulb to one terminal of the cell. Wrap the free end of the other wire to one leg to the aluminium clip. Take another wire and connect its one end to the other terminal of the cell. The torch is ready to work. Working: connect the only free and left with the aluminium clip. The bulb will start to glow. Flow of electric current. For electric current to flow, the following 3 conditions are necessary: a current producing device like cell, battery, etc. A wire which allow the electric current to flow through easily. An unbroken loop of wire connecting one terminal of the source through various appliances back to the other terminal of the source. See this picture. Next is cells. Electrochemical cells. All cells are source of electric current. Basically, cells are of 2 kinds: primary cells and secondary cells. Primary cells. Primary cells are the cells that produce electricity from the chemicals stored inside them. When the chemicals are all used up, the cells stop working. Example, they stop producing electricity. These cells cannot be used again. Dry cells and simple voltaic cells are two examples of primary cells. They are mainly used in torches, wall clocks, toys, etc. Secondary cells. Secondary cells are the cells that provide electrical energy to the gadget as a result of chemical reactions taking place in them. In these cells, the chemical reaction is reversible and the electric energy can be restored in them. Such cells are also called rechargeable cells. Lead accumulator and iron nickel accumulator are two examples of secondary cells. Next is dry cell, battery cell. Dry cell, also called battery cell, is a source of electricity. It generates direct current DC due to chemical reaction that take place inside it. A single dry cell gives voltage of 1.5 volts. The dry cells are available in different sizes and shapes. The dry cells used in torches, transistors, toy and clock etc. was invented by G. Leclerc in 1868. A dry cell consists of zinc container that act as a negative terminal. Inside this, a paste of ammonium chloride is filled. A carbon rod having a brass cap is placed at the center of zinc container. This carbon rod with metallic cap acts as a positive terminal. The carbon rod is surrounded by a mixture of manganese dioxide MnO2 and powdered charcoal. The remaining space in the container is then filled with a thick paste of ammonium chloride NH4Cl. The cell is sealed from the top with the top with pitch. The outer side of the zinc container, except the bottom, is covered with a cardboard cover. In a dry cell, the electric current flows from carbon electrode to zinc electrode. Now, advantages of dry cells. Dry cells have the following advantages. First is small in size and lightweight. Second one is no fear of leakage or spoilage. Can be easily transported from one place to another. Next is batteries. In everyday life, cells are almost always said batteries, but this is scientifically incorrect. As you know, a battery is made up of two or more cells joined together. The car battery used in car is big and heavy. It is normally made up of 6 cells, which use chemicals to produce electricity. When these chemicals are used up, the battery stops working. Electric circuits. The complete path of one terminal of an electric cell through the bulb and back to the other terminal of the electric cell is called electric circuit. This is a picture which shows you an electric circuit. The circuit in which electric current flows from one terminal of a cell or battery to the other is called a closed circuit. In a closed circuit, current flows from the positive terminal of the cell to the negative terminal. The circuit in which electric contact at any point is broken is called an open circuit. No current flows in an open circuit. Here is a picture given to you, an open circuit and a closed circuit. Let's see an activity. Aim of the activity: to identify the inside of a dry cell. Material required: a discarded or dead dry cell. Procedure of the activity: take a discarded dry cell, cut its side open, observe the inner contents and list them. Observation: the cells contain a black colored rod with a brass cap. an outer container of the greyish metal, a black colored powder mixed with a white paste. The mixture has a strong smell of ammonia. Sometimes a bulb does not glow even if it is connected correctly. Observe electric circuit carefully. You will notice that filament of a bulb is broken. Due to this break, the path of the current between the terminal of electric cell will break. Hence, no current flows in the electric circuit and bulb does not glow. Such a bulb is called fused bulb. Why does a fused bulb not glow? Bulb has small filament inside it. As long as its filament is intact, it glows when connected to a cell. A bulb is said to be fused when its filament is broken. The broken filament cannot complete the circuit. As a result, current cannot flow through the filament and the fused bulb does not glow. Symbols of a few electrical components. Cells, bulb, switches and wires are some components of electric circuits. A circuit with two electrical cells, batteries, a switch and a lamp, the torch bulb, can be drawn. One way is to draw the circuit with an actual drawing of the components, which will be very cumbersome. Another way is to use symbols for various components. The symbols for the commonly used components of a circuit are given here. See this table, symbols and electric components. Circuit diagram. A diagram which shows the arrangement of various components of electric circuit with the help of their symbols is called circuit diagram. This is a circuit diagram given to you. Electric switch. The on-off mechanism in any electrical circuit is controlled by a switch. When the switch is in the off position, the circuit is open and the current does not flow through the circuit. When the switch is in the on position, the circuit is closed and the current flows through the circuit. Switch on and switch off. Conductors and insulators. Conductors. The materials which allow flow of electric current through them are called conductors of electricity or electrical conductors. All metals, gold, silver, copper, iron, aluminium, salt solutions, moist air, impure water, graphite and even the human body are good conductors of electricity. Next is insulators. The materials which do not allow flow of electric current through them are called poor conductors of electricity or insulators. Dry air, pure or distilled water, dry wood, glass, dry clothes, paper, plastic, cotton, rubber, etc. are some examples of insulators. Cautions with electricity. A danger sign is displayed on electrical poles, substations, transformers, etc. This is to warn people against the dangers of electricity. Electric current is very dangerous whether generated in power plants or by portable generators. Although the electrical devices used at homes, in offices and factories are designed in such a way that the safety of the consumer is ensured. Even then, accidents or mishappenings can be occur unalarmingly. This result into serious injuries, permanent disability or even death. Therefore, to keep safe, we should strictly follow these precautions. First is, never play with socket or electric wires. Never touch an electric switch, plug or device with wet hands. Wear dry rubber slippers or stand on a dry wooden or plastic base while using electrical appliances. Never switch on or off a geyser while barefoot, especially if the floor of the bathroom is wet. In case of a short circuit or a spark in the switch, put it off immediately with the help of plastic or a wooden stick. In case of a fire in electric wires, never use water to extinguish it. Instead, first switch off the means, then use dry sand to extinguish the fire. Let's see an activity. Aim of the activity: to test the electrical conductivity of given materials. Materials required: 3. A bulb, a dry cell, connecting wires, wooden tape, a piece of cardboard 10 cm into 10 cm, 2 nails or screw, few objects to be tested like a sewing needle, hairpin, ice cream spoon, metal spoon, eraser, matchstick, etc. Procedure of the activity: connect the bulb with dry cell and 2 nails with the help of connecting wires and place them on the table. Fix the 2 nails on the cardboard at a gap of 2 cm between them, as shown in the figure. The conductor insulator tester is ready to use. Pick an object whose material is to be tested. Keep it on the nails in such a manner that the object touches both the nails simultaneously. Conclusion: the material of sewing needle, hairpin and metal spoon are good conductor of electricity, while those of ice cream spoon, eraser and matchsticks are insulators. Applications of electrical conductors and insulators. Conductors and insulators are very important to us. Based on their properties, they are extensively used in electrical devices and circuits. Some of their uses are as follows. Metal, which are good conductors of electricity, are used for making electric wires, switches, plugs, sockets and inner part of the electrical devices. Insulators like rubber and plastic are used to cover the electric wires so that they do not give an electric shock to the user. Electricians use rubber insulator gloves while working to safeguard themselves against electric shock. All electrical appliances and tools have their handles coated with insulating materials like rubber or plastic to prevent accidents. Insulator wires, pliers with rubber coated handles. Why is the handles of electrician's screwdriver made up of plastic? A screwdriver is made up of steel. A steel is a good conductor, so electricity can easily flow through it. Plastic is an insulator and does not allow electricity to pass through it. So, the electrician's screwdriver has a plastic handle to protect him for any electrical shock while working with live wires. Why are copper wires usually covered with rubber or plastic? A bare copper wire carrying current, if touched, gives an electric shock. Such wires may also cause fire due to short circuiting and electric shocks. Copper wires are covered with rubber or plastic coverings. Okay, let's quick revise with Reader's Digest. Electricity is a form of energy which is very useful in our daily life. All cells are source of electric current. Basically, cells are of two kinds: primary cells and secondary cells. Dry cell generates direct current DC due to chemical reaction that take place inside it. The complete path from one terminal of an electric cell through the bulb and back to the other terminal of the electricity cell is called electric circuit. The material which allow flow of electric current through them are called conductors. The material which do not allow flow of electric current through them are called insulators. Okay class, we have done our chapter. Now it's time to take your leave. Thank you.